Okay then, hello and welcome to another session with Mr. D, another maths lesson. I hope you found the lessons thus far okay. We are doing a new topic of fractions. I don't know, for some people that can be a little bit daunting. You see the word fractions and you think, crikey, this is really tough stuff. But hopefully you've seen and we're slowly unpicking that it's actually not too tricky. And we're going to do even more stuff with fractions and you're going to be absolutely fine with it. So I've got that bit written down here, and that's the most important thing that we need to keep in our heads when we're looking at fractions, is that a fraction is part of the whole. Keep saying that over and over in your head, a fraction is part of the whole. That's all you need to remember when you're looking at fractions. It's just part of a whole, and your whole can be anything from the pizza and the cake that you usually think of with fractions, or it can be a number, or it can be a thing, and a part of that whole is the fraction. And another thing to keep in mind when we're talking about fractions is that those parts are equal parts. So for example, we were counting in the fraction yesterday of what were we counting in? We were counting in we were counting in tenths. Now, a tenth is a fraction. That's that scary thing here. But we know now that it's not really that scary. All that it's saying is that I have my whole, and I've divided it, that fraction line, into 10 equal parts. My whole was a chocolate bar, but it could be a number, and I could divide 10 into tenths, and then have 10 tenths. I could divide a chocolate, an orange, a cake, a number, a car. I can divide absolutely anything into a fraction, and this fraction here is tenths, so I'd be dividing it into 10 equal parts. And the numerator, our top number, shows us how many parts that we have. So in this case, I have 1/10 of my whole. I had a whole, I split it into 10 equal parts, and I have one of those parts. That is what this fraction is saying. The bottom number is your denominator, that's how many parts you split your whole into. The numerator shows you how many parts you have, and this line here is a fraction line, and you can treat it a bit like divide. We've divided the whole into 10 equal parts. And this here is called, or what's known as a unit fraction. It's a unit fraction because the numerator is 1. We don't have to divide a fraction into 10 equal parts. We could divide it into 4 equal parts, into quarters. And I could have 3 of those quarters. Is this a unit fraction? Well, it's not, no, because my numerator, is more than 1. I have 3 parts. Is it a whole? Do I have my whole back together again? Well, I split my whole into 4 parts, and I only have 3 of my parts, so do you think that's a whole? That's not a whole either. This is a non-unit fraction. It's a non-unit fraction because the numerator is bigger than 1. Here, the difference being that I split my whole into 4 equal parts rather than 10 equal parts. A bit of a challenge question for you here is that these are both fractions. There's nothing scary about them, but there's something different about the parts. Do you think the parts are going to be bigger in a tenth or a quarter? That's a tricky bit. That's a bit of a challenge question for those people that have really got a good grasp of fractions. What happens to the part size as your denominator gets bigger or smaller? So think about that chocolate bar yesterday, and we split it into 10 equal parts. Think about how small the parts were. Imagine that same chocolate bar, but now split it into 4 equal parts. Are my parts bigger or smaller? And another fraction that we could look at is I could have 5/5. Again, is it a unit fraction? No, because the numerator is bigger than 1. What is interesting about the numerator and the denominator, though? They're the same, they're equal. And what do we, when the numerator and the denominator are equal, when they are the same, it is called, we have a whole again. I had a whole, I split it into 5 equal parts. I have 5 of those parts and must have all of my parts back together again. That is a whole. When the numerator and the denominator are the same, that is a whole. A fraction is just part of the whole. How are we feeling about fractions so far? We should be pretty good, I think. We should be pretty good. We're going to look at some more fraction work today, but before we get started on that, I thought that we could just look at some fluency, and then I'll try and beat my times table score, and then we'll get going. So here we have your questions here. You can pause the video if you want to now. I'll make that bigger first so you can see it all, because sometimes my head gets in the way. Pause it and have a go yourself first, and we'll go through the answers. I think I've already done. No. So these two you have to do in your head, these two with a written method. The first one was 384 add 30. Now, this one, what's interesting about this question here is that we're only adding 10 or 30, 3 tens. We're only adding 3 tens. So that's really easy, isn't it? Because we can just count up in tens. You can either keep the whole number in your head and count up in tens, or you can partition the number into and isolate the tens, get the tens on its own and add it up that way. I'll show you both those methods now. 384, add 3 more tens. Well, what's 10 more than 384? 394. Notice how none of the hundreds or the units changed. But if I have 90 and I've got to add 2 more tens, if I add another 10 to 90, I've got 100. So I have to bridge up to the next 100. So it was 394, 300, 404. 404, add another 10 is 414. That's doing it in my head. How that looks in my head is I've got that number line, haven't I? I'm starting with 384 and I'm doing jumps of 10. So 10 will be 394. And here's the tricky bit here. I've got to bridge, I've got to go to the next 100 because I've got 90, and the next 10 up is 100, but I've already got 3 hundreds in my 100 column. So I'm going to have 400, but the units will stay the same. That was 6, it is a 0, no 10s, a placeholder. Add my other 10s, 414. Secondly, another method you could deploy is the partitioning method. 384 add 30. Now I want to get just my 10, so I have 8 10s, so that's 80. What's my other part going to be? That's right, 304. And then now I can add that up really easily together. 30 add 80, 80 add 30, 80, 90, 100, 110. And then 110 add 304 is 414. Super. So far, so good. Next is we're going to need a written method for this one, aren't we? 34 times 4, because I don't know my 34 times table, nor do I know my 4 times table 234. So I'm going to use that magic column method, make sure everything's in the right columns. And from here you can do 2 things, can't you? You can do an expanded method where you do each sum on its own and then add it up all together, or you can do a non-expanded method and do it all in one equation. I'm going to show you through both, but you use the one that's most appropriate. If you get the right answer, that's what's important at the end of the day, isn't it? So the first thing we do, we have to start the ones, don't we? 4 times 4, 4, 8, 12, 16. 4 times 4 is 16, and sometimes I like to write the sums that I'm doing at the side just to make sure I'm really getting everything right. So 4 times 4 is 16. If you're doing that expanded method, you would put 16 in the correct columns and then do 30 times 4, put it underneath and add it all together. And that's fine. The non-expanded method, you can't put that 10 in the tens column because you haven't finished using the tens. So the 6 can go in from 16, but that 110 from 16 has to be renamed, grouped, sorry, and put in the tens column. I usually put it at the top to save it for later. So we're not adding this 3 and 1 now. We're not adding it yet. So we have to do 30 times 4. So how I work these ones out is I do 3 times 4, which is 4, 8, 12. Then I have to times it by 10 again because to do 3 times 4, I had to make it 10 times smaller. So now when I do 3 times 4, it's 12. I've got to make it 10 times bigger. Some of you like to say I'm putting the 0 back on, but you're not adding 0 to anything. So be doubly sure with your methods there. 3 times 4 is 4, 8, 12. And I have to make it 10 times bigger, so it's 120. However, I have that other 10 to add on here. So it's 130, and I've not got any hundreds to deal with, so I can just bang that in there. There's my answer, 136. Pat on the back if you got 136 as well. 4 times 6, we're not going to waste our time there. I'm sure you know that 5 times 4 is 20. So 6 times 4 is going to be 24. 4 times 6, the same thing. Maybe see if you can do that one in an array or show it as a repeated addition. It's a bit of a challenge. And the last one, which is really good because we haven't done any division since we practiced. 76 divided by 4. So what I'm saying is, and this is really important for fractions later on, is I've got 74 now, that's my whole, and I'm dividing it by 4. And if you're putting something into 4 equal parts, if you're dividing by 4, you're splitting it into quarters. So you need 4 equal parts to 76. 76 is going to be split into 4 numbers that are all the same, but when added all together, make that 76 again. That's another way of looking at it. So how you guys could work this one out? Well, you could try and partition it, but if you know anything about 70, you'll know that 70 and 6, you'll know that 70 doesn't go into 4. You'll recognize the pattern, or you could do your 4 times table and you know that 70 won't go in to 4. So you're going to have to partition it a different way if you're going to use this method. So what we said is that we've got to get what's the biggest 10 that I can get from 76. What's the biggest 10 for our work? Where are we? What's the biggest 10 that I can make from 70 that goes into 4? Well, 10 doesn't go into 4, 20 goes, 30, 40, 50 doesn't go, 60. I'm going to do 10. I'm going to put 40. That's the biggest 10 that goes into 4. Goes into 4 10 times. And then what would be left? or 40, 50, 60, 70. Need 3 10s and the 6 1s left over. 40 and 36 is going to be 76. So then I can do 40 divided by 4 because I know my 4 times table. And I know that 40 divided by 4 equals 10. And then I know that 36 also goes into 4. 9 times. And then I'd add these two together to get my answer, 19. Some of you might be exploring the bus stop method. And that looks a little bit like this. We have 76, we have our whole, we do our bus stop, and then we put the number we're dividing outside. So then you've got to ask yourself, how many 4s are there in 7 10s? Or if you know that that's 7 10s, you can treat it like a 7 as long as you know in your mind that it isn't 7, it's 7 10s. How many 4s are there in 7? Well, there's 1 4, makes 4. Are there 2 4s? 2 4s make 8. Nope, I can only get one lot of 4, 1 10 in that 7. And how many do I have left over? Because 1 4 is 4, so how many do I have left over to get that 7? 6, I've got 3 more 10s that I can rename there. And that is now 36. How many 4s are in 36? 9. The last way that you might remember how to do is one that the textbook like to choose, but for me it doesn't really work. It does work, but for me I don't really like it, should I say. So you can do that method. It looks the same. You tell yourself how many 4s are there in 7 T. Well, I can get 1, and that's 40. Then I put my 40 that I have from my 10. 4 times 10 is 40. And I take that away. And that leaves me with 36. Then I do 4s into 36. Go 9. That's another way of doing it. Again, it doesn't really make much sense to me. I prefer this top method. However, you do have to know your division facts really, really well. Right. I'll go and try and beat my score and hit the button, and then we'll go and have a look at some new learning. Seeing some wonderful things on DB Primary, by the way, of your work. Please send that in. I think what I'll do later on is show you. I'll send you the link to my Google Drive, and you can send work and upload it on that. It's going to be a lot easier because I've made folders, and you can find the folders and then put your work into the right folder. Please put your name on stuff and title it so I know what it is you're doing. Right, I'm doing the 3 times table again, aren't I? I've got to beat a score of 36. I think one of somebody got recently. 36 is the score to beat. Wish me luck. I may or may not talk throughout this because I want to try and get the high score. I haven't won thus far. You guys are way more practiced than I am. 36 to score to beat, so let's go. I'm on a roll. Oh, dear. I'm thinking of a different times table. I've got to speed up, Mr. D. You've got to speed up. see if you can do it as quick as I can. No, 12, I've seen the wrong number. Oh no. Oh, rubbish. 29. Remember, try and 30 is that magic number. You can get 30, that's really good. 36 is the high score, but if you can get 30, then you should be really, really proud of yourself. That's a super score. Right then, let's get on to some stuff then. Let's look at, we'll do quite a bit today because it's quite easy. And I left you with this, didn't I? I thought it was fairly easy for you guys to do. Computer's being slow. There's some pages. Bear with me a second. Right, so we were looking at that one, and it would be to write the fraction, and then we're making that whole again. So you can see quite clearly here that this is my whole. It's not a number, it's just a rectangle. And my whole is split into how many parts? 1, 2, 3, 4, 5. You can get that down straight away. Yeah, your whole is split into 5. Yeah, that's your denominator. And the shaded part is 1/5. So how many more fifths do I need to make a whole? Well, it's nothing complicated. I've got 1. I need 1, 2, 3, 4. 4/5 will make that whole. Here I had 8/12. Nothing complicated. It's just your whole split into 12 equal parts. You could have probably split. You can probably split this shape in here into 12s if you want to. It'd be hard to make sure they're all equal, but I bet you could do it. This whole here is split into 12. It's nothing more complicated than a fifth. You'll just notice that you've got more parts, so each part is a little bit smaller. I have 8/12. How many more do I need to make a whole? So what is a whole going to be in 12? Well, if I've got 12 as my denominator, how many 12s do I need to make a whole? Well, I know that a whole is just the numerator and denominator that are the same. So 12/12 is a whole. I have 8, so I need to shade in 1, 2, 3, 4 more 12s. So 4 12s would go in there. I'm going to see if I have it on here. No, not yet. Seven eighths. So this is a little bit tricky because we're not making the whole this time, and I know it's not the whole because my denominator and numerator are not the same. I only have 7/8. That's my total in this fraction. It's not going to be my whole because I don't have my whole parts again. This is just in this diagram. That's the total that they want to make. And I have 2/8. So how many more eighths do I need to make 7/8? Again, the language might be getting more confusing, but when I'm talking about eighths, I'm just talking about those little parts, those little equal parts. I have 2 of them, and I need to get to 7 of them. I know that 2 and 5 make 7. You guys should know that as well. So 5/8 and 2/8 is 7/8. Again, these are really, really tricky one. I'll just throw here. So you've got 2 really complicated diagram here, but it's not that tricky. All it's saying is that this is my first problem here that we need to figure out. Well, you can do either or, I think. You could start here and say this is the total that it wants. It's not the whole because my numerator